Lesson 8.3 is about slope and y-intercept, and this is actually a very interesting and important lesson because you use this all the time in linear equation. Our essential question today is how can you use the slope-intercept form to graph a linear equation? First, we need to know what slopes are. A slope is a number represented in front of the x value, and it tells you how slanted your graph is going to be. What I put down right here are two things: vertical change over horizontal change. So whenever we see a vertical change, we're actually talking about the change in between the y values. And then when we say horizontal change, it means it's going to be the difference or the changes between the x values. A lot of times we're going to say these changes simply rise over run. So the y values are going to be the rise, and then the x values are going to be the run. I'll shortly explain how to use rise and run to find the slope. Now before I give you examples, you have two different types of slopes. One is going to be the positive slope and the other one is going to be the negative slope. For a positive slope, your graph is going to slant upward from left to right. For negative slopes, you're going to have the slants downward from left to right. So before you find your slope, you can kind of tell if it's going to be the positive or negative slope by looking at the features. So I have a graph like this, and for each of these units, there's just going to be one number. So -1, -2, -3, 1, 2, 3, and so forth. And then I have negative numbers on the bottom, and then positive numbers. Now, when I see my slope or when I see my graph, what I'm going to do is I'm going to try to find 2 points that will help me to count the units easily. So I don't want to put my 2 points any in between numbers. I want to have them a whole number as much as possible. And in this case, you'll find several different points. What I'm going to do is I'm just going to find 2 points that may help us to look at things. I'm just going to look at points that are going to give me whole number when I have rise over run as an equation, or it could be fraction as well actually. So I'm just going to pick points that are easy for me to count. I'm going to put this one, and then the next one, either you can go to the left and find something that's more on the top from the left side here, or you can choose something that's on the bottom. I'm going to choose something that's right underneath, and that would give me on the exact point on the corner instead of somewhere in between like here or here, because that's harder for me to find out the rise and run. So in this case, let's see. Whenever you count rise and run, you're going to always start from the left number and then go to the right. So in this case, this is going to be my left number, or the first one on the left. So I start from here. From this dot to this dot, I can only move in straight motion. So I can either go up or down, and then left or right. So let me put this in a blue. So from my first to second dot, I moved 2 units down. And then for my run, I moved 1 unit to the right. So my slope is going to be -2 over 1, which is in turn going to be just -2. Now my second one, if you want to pick 2 points to draw, I'll have this point and this point that you can use. So 2, 3, and then -2, 0. Those are your 2 points that you can draw to find out the slope or draw the graph. I chose these 2 points because these are the 2 points that you're going to have the point, the exact corner of it, instead of somewhere in between like this or like this. So I chose a number that would go into a whole number or integers, and then I count the rise and run. So I have to start from this left number because you always choose the left number first, and then you count the rise So up here, I move 1, 2, 3 to the top. And then to run, I'm going to move 1, 2, 3, 4 to the right. So my slope is going to be 3 over 4 for this case. And I know it's going to be a positive number because I moved up, which is a positive, and moved right, which is also a positive one. So if I want to identify these into different types of slope, this is going to be a negative slope, this is going to be a positive slope. You don't want to draw the graph all the time to find the slope because sometimes it's going to be harder or more complicated. So it's better to find the slope using the coordinates. So let's go ahead and use the coordinates to find out the slope. We're going to use the equation for the slope format, which is going to be difference in y coordinates over difference in x coordinates. I put a star next to the slope equation, and I have two y's and then two x's. So I have y2 minus y1 equals x2 minus x1. And these 2's and 1's are just saying which one is going to be the first set, which one is going to be the second set. So to give you the example, I'm going to give you two sets of points that you need to work with. So let's say I have 7, 5 and negative 2, 0, and I have to find out the slope. What I'm going to do is I'm going to find the differences, but first I'm going to set these two different points as x1, y1 and x2, y2. So my first set of numbers, coordinates, it's going to be 1's, so x1 and y1. My second set of coordinates is going to be x2 and y2, so the 2's. And then I'm going to plug into this equation on the left. So I put the equation one more time just so that I have it right next to my numbers. Y2 is going to be 0 minus y1, which is 5. x2 is negative 2 minus x1 is going to be 7. And then I just work with the numbers. 0 minus 5 is going to give me negative 5. Negative 2 minus 9 will give me negative 9. When I have two negative numbers, I actually have a positive answer because negative 5 divided by negative 9 is going to give me a positive answer. So 5 over 9 is going to be my slope. So it's going to be a positive slope and it goes up. And I used the coordinates and the slope format to find out the answer. I'm just going to give you one more example before we move on to the next one. So let's say I have two coordinates like this, negative 4, 3, negative 10, 9. So I'm going to use the same equation. I'm not going to write it again, but I will follow the same rule that I applied for the first one. So, and if it's confusing, you can always put x1 and y1 on top of your numbers like this, x1, y1, x2, y2. So let's go ahead and plug it in. Y2 is going to be 9 and y1 is going to be 3 over x2 is going to be negative 10 minus x1 negative 4. As you can see here, even though I have a negative number, I made sure that I have a subtraction so that I have something like this. We call it either clown face or however you remember it. So when you have these subtracting a negative number, you can actually change it into addition. So now your answer is going to be different. You're going to have 9 minus 3, 6, negative 10 plus 4. So you're going to have still a negative number, but it's going to be negative 6 instead of negative 14. And 6 over negative 6 is going to be negative 1. So that's going to be your slope. I have another star with special cases. Whenever you're finding the slopes, you're going to find some special cases that you are always going to have a certain number or certain answer. If you remember our last lesson, we have two different kinds of graphs that you'll find. Either the one that goes along this way when your y equals a number, or graph like this where your x will equal a number. Whenever you have a graph that forms either a horizontal or vertical line, they're always going to have the same answer. For the first one, y equals a number, you see that the graph is going to be horizontal, it's flat, so you really don't have any slope that you can either go up or down. So whenever you have y equals a number, it's going to be a 0 slope. It's a flat surface, nothing there, slope is 0. And when you have x equals a number, if you use the line test, you're going to have all the answers for your x on this one line. So you're not going to have any one answer or one slope because it's basically a wall. So your answer for these ones are going to be always undefined. So just think of it as if it's a y slope or y equals a number slope, it's a flat surface, no slope. If it's a wall, x equals a number, it's undefined because it's not a slope anymore, it's a wall. The last portion of it is using the equation to graph. And actually, I use this all the time whenever I have to graph it because it's the easiest way to graph an equation. First, we need to see the graph or equation as slope and intercept form. Slope and intercept form will have three components. You're going to have first y, and that's going to equal to mx, which is going to be your x, and then plus b. So let me explain these parts. So we know that y and x is going to be your x and y coordinates point. M is going to be your slope, and b is going to be your y-intercept. What is y-intercept? Y-intercept is a point where your graph is going to go across along the y-axis. So for example, let's say you have a graph. I'm just going to draw a random graph like this. And let's say you have a line that'll go across like this. Then your y-intercept is going to be this point. So that's going to be your y-intercept because that's the point that your line crosses the y-axis. Now, once we know this slope and intercept form, it's really easy to graph your equations because the slope you already know that is going to be rise over run, and then we know that y-intercept is going to be the point that the graph will go across the y-axis. So you already have one point given to you. It's going to be 0, comma, whatever the number you have, and then you'll just have to start from that point to find the slope. So let's say we have an equation like this. Y equals negative 1 over 5x plus 4. Whenever I have a negative number, I am just going to put it with the y value or x value, one of the things, so that I don't have to confuse myself. So let's say I have a graph like this. Each unit is going to be just 1 so that I don't confuse myself. And then I am going to start with finding my y-intercept. According to this equation, my y-intercept is going to be positive 4. So I'm going to go ahead and look at 0, positive 4, so it's going to be right here. And that's going to be my starting point for this equation or for the graph. What I'm going to do afterwards is going to look at this, which is going to be the slope, and my slope is going to be negative 1 over 5. That means I actually went down 1 because it's either rise up or go down. So in this case, I go down 1 unit, so it's going to be right underneath here. And then I move 5 right side because it's going to be a positive number. So I move 1, 2, 3, 4, 5. So my new point is going to be here where it will be 5, 3. And then when you connect these two, you are done graphing for your equation. So if you want to double check it, you can use these 2 points as your coordinate points and then plug it into your equation. So my points were 0, 4 and then 5, 3. So let's go ahead and plug it in to our equation and see if it's correct to check. So I check. It's going to be always the first and second. So what I'm going to do is I'm going to put the second number, which is 5, 3, as my second point. So I do 3 minus 4 over 5 minus 0, which is going to give me negative 1 over 5. So I know that I have the correct slope, I know I have the correct y-intercept, and that's how you check your answer. When you're working with this, if your equation is not in a form of slope-intercept form, so y equals mx plus b, you'll have to change it into the slope-intercept form first, and then you'll be able to graph it. For your homework for this lesson, draw a rubber duck next to your name.